Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. So today we will continue our lesson on chapter 4 in Mechatronics System Design entitled Actuating Devices. Right, so let us proceed. Right, before we proceed with our lesson, let us take a look on the objective for today's lesson. So, at the end of this lesson, you should be able to describe processes in selecting an actuator. So for the first objective, you will learn on how you can select your actuator based on the specification stated in the datasheet. The second objective is to explain the specifications and characteristics of DC motor and AC motor. So in this chapter, you will learn some of the example of the DC motor and AC motor which will be used in your project later on. And the last objective is to describe the modeling part of the actuator in mechatronic system. Right, so when you are given the questions, so what is the part of the modeling system for your motor and how you want it to do that? So you can learn in this lesson or in this chapter. Right. Okay, now as you can see here, we have two different mobile robots. So the first mobile robot, it is used to spray the pesticide in agriculture, and the second robot, it is used for underwater operation. Right, so each robot has its own function, and when it wanted to perform its own function, it must have its own specifications. Okay, so the specification, sometimes it is similar, but sometimes it may be different. Right, when you are designing a mechatronic system, you will need to know what is the design specification of your system. Is it able to solve your problem? Is that specification is able to deliver the tasks that are provided by the problem? Okay, so first and foremost, one of the design specification that is important for you is the application. So what is the application of your system, and how the design of your system will applies to the application that you intended to do. All right, next is the height of the robot. Okay, size of the robot, is the size is suitable for the operation. The weight of the robot, is the robot is too light or it is too heavy. Okay, so you need to know. Okay, and then the payload. Okay, when you are choosing your motor, you need to know either the motor is able to withstand those kind of payload or not. And then what is the acceleration of the motor or acceleration of the robot? Does your robot want it to move fast or slow? And then the speed of your robot, how it wanted to maneuver. If your robot, for example, wanted to turn, so when it is turning, you wanted the robot to turn in high speed or not. Okay. And next is the power. What is the power of the robot? What is the battery or battery supply of the robot, and so on. Okay. So there are some of the example of the design specification in mechatronic system. So before you are designing the real system, you need to know what are the design specification of the system, so that you will be able to fulfill all of those demands, all of those objectives when you are implementing your system later on. All right. Okay, next we will go, what is actually an actuator? Now let's take a look on the video that will show what is actually an actuator.
In very simple terms, an actuator is a device that makes something move or operate. Every one of us takes advantage of at least one actuator every day. When we go to the grocery store, the door opens automatically for us. An actuator makes the door open. We can move the car seat forward or backward before we drive away in our car. An actuator makes the seat move. An actuator can move something in a straight line, also referred to as linear. Also, an actuator can make something move in a circular motion, also referred to as rotary. We've talked about the movement of an actuator, but we haven't discussed how or what makes it move. An actuator receives a source of energy and uses it to move something. To put it another way, the actuator converts a source of energy into a physical mechanical motion. In this example, the butterfly valve is operated by turning the hand wheel connected to the rotary actuator. In industrial applications, the hand wheel could be replaced by one of three typical sources of energy, which can operate the rotary actuator. Electric actuators use some form of electric energy to operate. Hydraulic actuators use a variety of liquids as a source of energy. Pneumatic actuators are operated by compressed air. Typical actuators in the industry include electric motors, hydraulic motors, and pneumatic control valves. Let's look at a typical pneumatic actuator in action. The PLC analog output card produces a 4 to 20 milliamp current to move the valve from fully open to fully closed. The 4 to 20 milliamp current will be converted to pneumatic pressure, which becomes the source of energy to operate the actuator. Okay, let's review what we've discussed. An actuator is a device that makes something move or operate. An actuator can move something in a straight line, referred to as linear, or in a circular motion, referred to as rotary. An actuator receives a source of energy and uses it to move something. In other words, the actuator converts the source of energy into physical mechanical motion. That source of energy can be in three different forms: pneumatic, electric, and hydraulic. Typical actuators in the industry include pneumatic control valve, electric motor, and hydraulic motor.
Alright, so let's take a look on the definition of an actuator. So an actuator is a part of a device or machine that helps it to achieve physical movement by converting energy, often electrical, air, or hydraulic, into mechanical force. So basically, an actuator is like a device or an object that will convert one energy into mechanical force. So the energy that it converts from, maybe it is electrical, maybe it is air, or maybe it is hydraulic or oil. Alright, so those what they call the conversion, it will convert it into movement. We call it mechanical force. Okay. Right, so an actuator requires a control signal and a source of energy. So when you are designing your actuator later on, you need a control signal. Alright, so a control signal usually in terms of like maybe you can give some signals in terms of voltage, in terms signals of digital signals, okay? And then when the motor or the actuator receive those kind of signals, they need an energy. So they need a source of energy for it to move, okay? When you give the sign for the actuator, okay, now, alright, so right now I need to move, but I don't have the energy. So you need to supply the energy for the actuator, okay? So the control signal is relatively low energy and may be electric voltage or current, pneumatic or hydraulic fluid pressure, or even human power. Okay, so sometimes we push the button, okay, and then the button, it will give some electrical voltage, or we rotate something, so that is human power, right? So from there, the actuator will receive the control signal and they need some energy for it to move. All right. So its main energy source may be an electric current, hydraulic pressure, or pneumatic pressure. So the source of the power of the actuator, maybe it can be electric, okay, for example DC motor, AC motor, hydraulic pressure, for example hydraulic motor, or pneumatic pressure, for example pneumatic motor, right? So when it receives a control signal, an actuator responds by converting the source of energy into mechanical motion. So when what I call the first thing first, when we give the signal for the actuator to move, and the actuator will receive the energy from the sources, either it is electrical, pneumatic, or hydraulic, and then from there it will convert those energy into mechanical energy. So it means that it will start to move. The actuator will start to move. Either it is in linear or either it is in rotary. Okay. Right, so this is the example of the actuator. For example, you have a DC motor and you can also have a hydraulic motor. So where this is the hydraulic liquid which is flow throughout this holes here or throughout this valve here. Okay, and when it is flowing, it will rotate the motor. Right, for the DC motor, you have the supply here, positive, negative here, and then the electric current will make the motor to move. Alright. Okay, so that is actually the definition of an actuator. Alright, so what is the concept of the actuator? Okay, so that's the previous slide shows like the theoretical part of the actuator. Okay, and then in this part we will understand the concept of an actuator, on how the actuator works. Okay, right, so this is the example of the control signal, okay, which produced from the microcontroller. We call it Arduino. Okay, so the Arduino will give the control signal, and then it will give to the power amplifications and modulations. All right, so because the control signal usually consists of a very low current or low voltage, so it will not be able to what do you call move the motor. Okay, that's why we have unmodulated energy source. So this energy source, we goes to the power amplification. It will amplify the power, okay, of the energy source here, and it will goes to the energy conversions. All right, so from the control signal, the actuator get the energy from the unmodulated energy source, and the power will be amplified, and then it will convert from the voltage to the output here. Okay, output is the actuator, so it will move the actuator. All right, so in this case, it will rotate this motor. All right, okay, so from the control signals, it goes to the power amplifications, and power amplification also receive energy from the unmodulated energy source, and then it will convert the, for example, this one is a voltage, the electrical power, it will convert into mechanical power, so it will move the motor here. So that is the actuator concept. Right, next is the types of actuators. So when you are operating the actuator, there are two types of actuator. Okay, so the types of actuator have been classified in terms of the movement of the mechanical power. So the first part is the linear actuator. Right, so for linear actuator, it is actually the movement of actuator in linear. It will move either, okay, this way or this way. You have a linear movement of the actuator. So the linear actuator, usually we are using the unit of force in terms of Newton, unit of speed in terms of meter per second, because it is in linear. Okay, it has the distance. Okay, and then we are also using the unit of distance per stroke. Okay, so the distance in every stroke. What is the distance in every stroke? Okay, so the unit for linear actuator, we are using meter or Newton. Okay, so that is linear actuator. So next is rotational actuator. So obviously the name itself says that it is rotating. Okay, so when it is rotating, we are using the unit called torque. So torque is actually in Newton meter. Okay, and then in terms of speed, we are using rotational per minute. Okay, rotation per minute, RPM, or radian per second, because the rotation actuator, it is related to the angle, or it is related to the rotation. RPM is actually the revolution per minute. I'm sorry. All right, and then we also using the unit of angle. Okay, either it is in radian or it is in degree. Okay, because rotation, it is related to the angle, and linear, it is related to the distance. That's why the unit is in meter. Okay, that is two types of actuator that have been classified in terms of the movement of the actuator. Either it is linear or it is rotational. All right, next we go to the top speed characteristics of an actuator. All right, so as you can see from this figure, the first figure here, okay, we have the torque in y-axis and we have the speed in x-axis. Okay, and then we have the DC servo, AC servo, or stepper motor. All right, so first thing first, torque is actually the work done from your actuator. Okay, So the formula is actually force multiplied by the what do you call, the distance or the radius of the motor, or the radius of the what do you call, the movement of the object. Okay, so the higher the torque, the lower the speed. Okay, so when, for example, if your motor done a lot of work, okay, it means that the speed of the motor must become reduced. Okay, because they are doing a lot of works. That's why we cannot operate in higher speed, because it is doing the work. Okay, that's why, as you can see here, this is where the point of torque, okay, where it is actually, we call it like a stall, what do you call, stall torque. Okay, stall, it is the motor, it is at stall, because it is at maximum torque. Okay, maximum work that it has done. All right, and it makes the speed to stop, because this is the value of 0 here. Okay, and then here, as you can see here, the speed is at its maximum, okay, when the torque is equals to 0. Okay, we call the point here is no load speed. Okay, the speed where there is no load. All right, and then as you can see here, when we put an additional load here, okay, we can consider it as operating points, where it is actually the most optimized area where your motor can operate. Okay, where it has, for example, the torque is at what do you call, in medium level. All right, and you can operate those motor efficiently during these operating points. So that is torque speed characteristic. Torque is actually the work done by your speed. Okay, the work that has been done by your motor. Okay, right, this is the second graph, shows the engine power and torque curves. Okay, right, as you can see here, power is actually what do you call, we are getting from the multiplication of speed and torque. All right, so obviously, if the higher your speed, the higher the torque. I'm sorry, if the torque is higher and the speed is also high, the power will become higher. All right, and then as you can see here, the power is maximum here because the speed is keep getting higher, and the torque is keep getting lower, but it still need to increase the power. All right, because when you need to do some work and you need to do the work quickly, so you need a lot more power. Okay, but if you are doing if you wanted to do some work quickly, but your work is not that much, that's why your power is reducing here. Okay, all right, so that is the relationship between the power, the torque, and the speed. Okay, so if you are doing some work and you need to speed up your work, you need some power. Okay, you need to increase your power in order for you to speed up the work. But if you are doing a work and you wanted to slow down the work, I wanted to do it in a slow pace, so it means that you just need to lower down your power, so you can do it slowly. So that is the concept of power, torque, and speed. All right, so next, let's take a look on the actuator selection process. So how you wanted to select an actuator? What is the criteria when you are selecting some actuator for your applications? All right, actuator and driver selection. So determine the load and load special condition or operation, torque, load, initial, and special requirement. So the first thing first, okay, when you are selecting your actuator, you must know what is the load of your system, what is the maximum load of your system, and what is the minimum load of your system. Because the motor or the actuator, it is actually used to perform or to move the load, right, to operate the load. That's why you need to, first thing first, you need to determine the load. Okay, maximum load, minimum load, or the special condition. All right, or any what I call other specification of the load. Right, so from there you can choose, oh, this motor can withstand those kind of loads, so I can use this motor. Okay, but if you choose the motor that could not, for example, carry out the load, so when you are carrying when you are performing your operation later on, the motor will not even move. Okay, And then if if the load is higher than the load of the motor and the motor didn't move, it will overheat. Maybe the motor will be overheat and it will give the back EMF to your circuit, and your whole system will be damaged. So that is why determining the load is one of the most important part of selecting an actuator. Alright, next is to determine the actuator type and sizing based on the torque required. Okay, so next is you need to determine what is the size or what is the type of your actuator. You want it to use DC actuator, AC actuator, hydraulic actuator, or pneumatic actuator. Okay, so based on the work that are required. Okay, for example, when your system is you don't have any powerful electrical supply, so you need to use maybe hydraulic or pneumatic, right? So that is the one that you need to determine. Okay, motor size, motor power, rated speed, voltage and current, and also the gear head. Okay, alright, so when you are using the application of the motor, you also need to know what is the gear ratio, okay, of your motor, because you wanted to determine the torque and determine the speed of your motor. Alright, so next is determine the actuator driver, for example the modulator, based on the actuator specification. Alright, so the actuator driver or modulator is actually like we call it a motor driver, okay, where it will process the conversions of the energy. Okay, for example, if you are using electrical motor, it will convert from electrical supply to the signals or to the way that your motor can move. Okay, it will amplify the signal or amplify the voltage or amplify the current. So it is depending on the application itself. Alright, so it is like the middleman between the supply to the motor. So it will process all of the related things, PWM, okay, and also the direction of your motor. So the modulator will do that. Alright, and then next is you need to determine the suitable actuator control signal based on the driver. Okay, so next is you need to choose either you wanted to perform your motor based on the PWM, based on the UR, or based on the I2C signals. So you need to determine. Okay, but usually when you are determining, for example, I wanted to use PWM motor, so you need to find out what is the motor that use PWM signal as their motor signal or control signal. Okay, I wanted to use I2C signal for my actuator, so you need to find what are the motor that is use I2C signal to perform their work. Okay, so next you need to determine the suitable actuator control signal. Alright, so from the summary here, when you are selecting actuator and driver, first you need to know what is the load. Okay, what is the load of your work, and then from there you can determine your actuator type and sizing. Okay, so whether electrical, pneumatic, hydraulic, AC or DC, you need to determine it. Alright, and then from there you can determine the size. Either the motor is bigger, is it your system can allocate a big motor, or only able to allocate a small motor, and also the power, rated speed, voltage and current. And then you need to determine or finding the suitable driver or suitable modulator for your motor. Okay, so if, for example, you find the driver which, for example, 20 watt, but your motor can perform 80 watt. So it means that when your motor is, getting a lot of power, okay, it will not perform perfectly because the modulator can only provide it until 20 watt. Okay, so you cannot get the privilege of 80 watt power of the motor. Okay, and lastly is to determine the suitable actuator control signal. So either you want to use PWM, UR or I2C. Alright, next is load identification. Okay, so the first part of your system. Alright, so this is the example of a wheel of the mobile robot, okay, where it is actually we put it in an inclined surface, okay. And then this inclined surface, we have two forces, okay, forces in y-axis and forces in x-axis, okay. And the forces in y-axis, it is actually being balanced by the forces mg here, okay. and the only forces where what do you call the robot will move is in the x-axis here. Okay, and then you have this equation mg sine theta, also mg cos theta for x and y axis, and then from there you will have the torque here. Okay, torque equals to the force multiplied by the radius of the wheels here, and then you will get, okay, the summation of the force in x-axis because the motor is moving in this x-axis. Okay, all right, so you will get the force of in x-axis, and from there you can calculate, right? You can calculate the torque of your system. Okay, all right, so the torque is actually the work, right? The work that needs to be done. All right, and then from this website you can go to this website, robot shop motor drive sizing, drive motor sizing tutorial, and you can give, for example, the input of the system that you have. For example, this is the mobile robot. Maybe you can put the input of the mass of the mobile robot, number of drive motors, radius of drive wheel, velocity, maximum incline, all right, supply voltage, desired acceleration, desired operating time, and total efficiency. So you can put all of this input and it will calculate the angular velocity, okay, the torque of your motor, the total power that are required per motor, maximum current from per motor, and also the battery pack that you need to have. Okay, so this website can provide the load identification for you. Okay, right, so that is load identification, where you need to determine the load of your system. Okay, so that when you're choosing your motor later on, your motor will be suitable for the application. Right, next is the actuator selection. Right, so for actuator selection, determine the actuator type and sizing based on the torque required. Either it is a motor size, power, rated speed, voltage and current, and also the gear head. Okay, so maybe you can select the pneumatic, DC motor, stepper motor, servo motor. So that is all depending on your application lah. Okay, so that it will solve your problem. Next is modulator selection. So determine modulator, or what they call actuator driver, we call it modulator, based on the actuator specifications, right? As I've mentioned to you before, you need to know what is the power of your motor so that you will be able to select the best motor driver for it. Okay, with the usually we are choosing higher rated power of the modulator compared to the motor. For example, if your motor is 50 watt, we are choosing 80 watt modulator. Okay, and then the type of your motor. For example, if you are using DC motor, you cannot use AC motor modulator. Okay, so for example, another example is if you are using AC motor, you cannot use pneumatic motor modulator. So you need to know what kind of motor that you are using and what is the rated power and how you want to choose the best modulator for your system. Okay, so this is the example of TB6600 stepper motor driver. So if you are using stepper motor driver, you need to use if you are using a stepper motor, you need to use stepper motor driver. Alright, so this is the example of the MD10C DC motor driver, which is from Citron. So I think this motor driver is usually used by our students, okay, because they are from Citron. So you can just buy it from the website. Right, so this is actually using to drive the DC motor. Okay. Alright, so next let's take a look on some of the example of the case study where they are choosing their their actuator. Right, as you can see here, so this is actually a quad rotor. Okay, so when you are designing a quad rotor, you must ensure that this quad rotor must have small size of motor. Okay, so the motor must have a very small, because if you have a large motor and heavy motor, so your quad rotor will not be flying throughout the sky. Right, so your motor must be light and also small. Right, that's why we have motor B here, okay, which is the DC motor. So the torque here is 550 gram per motor, which is equals to 2.2 kilogram. Okay, when we have 4 motor, it is the weight of the total motor is 2.2 kilogram because it is times 4. The motor is 10.8 volts at 11.2 ampere. Okay, and the driver, which is the modulator, we are using IR F7456 power MOSFET, 16 ampere, 20 volt. As you can see here, the motor is 11.2 and the driver is 16 ampere. So usually we are choosing a higher rated driver, okay, compared to your motor. Okay, and then the battery that we are using is 5000 milliamp hour, which is lasts about 5 minutes. That is motor B. So you have two options. Okay, the first option, the next option is motor A. Okay, this is brush motor and this is brushless. Okay, so for brushless motor, okay, the torque is 950 gram per motor, so it has a total of 3.76 kilogram. So is your actuator or is your system can withstand 3.76 kilogram? Okay, so you need to determine that. Right, so this motor is rated at 12 volt at 20.6 ampere, and the driver is from 7.2 to 14.4 volt at 30 ampere. Alright, so as you can see here, the driver rated voltage and current is higher than the motor itself, and the battery that we are that maybe used is 3000 milliamp hour. Maybe it will last about 3 minutes. Right, so from this, obviously lah, we can say that maybe we need to use the motor B. Okay, because the battery is like can withstand what do you call longer. The weight is not that much, but sometimes maybe we need to have some weight on the quad rotor to reduce its sway later on when it is flying. Okay, so that is all depending on your applications. All right, so this is the example of the modulator. Right, so next we have the example of the agribot. Okay, so for the agribot, we have the 16 Newton meter per motor. Okay, because the weight of the robot is 40 kilogram, and this is the speed, this is the acceleration, and also the skidding mechanism, and we also have rubber wheel. So obviously rubber wheel will have some, you know, frictional force. Okay, and the power supply for the motor is 24 volt DC. Okay, onboard battery. All right, and then this is the motor that we are using. Okay, all right, so this is 350 watt motor. Rated speed is 3000 rpm. Okay, and the gear ratio is 9.78 with ratio with 1. Actual speed is 300 rpm, and the weight of the motor itself is 2.97 kilogram. Okay, and the power of the motor is 24 volt DC. Okay, which is similar to the power supply. That is why we need to know, okay, if the power of the motor is 24 volt, so you need to have 24 volt supply. Okay, and the current when it is at full load is 11.7 ampere, and the rated torque, which is 11.1 newton meter. Right, and this robot is also has a chain transmission. Okay, when the small sprocket is 8 and the wheel sprocket is 25, so the ratio is 8 to 25. All right, and the input torque is 11.1, the output torque is 34.72 newton meter. Okay, and then next we have this is the modulator. We are using the motor driver MD30C. Okay, the motor driver voltage is from 5 volt to 30 volt. Okay, so it is actually higher compared to the voltage of the motor. Okay, and the maximum current that it can withstand is 80 ampere, which is higher compared to the full load of the current of the motor. Okay, and it also have the reverse polarity protections. All right, and this robot is provided or recall supplied by the lead acid battery, which is from 24 volt, which is operated in 10 ampere. Right, okay, as you can see here, the battery is only operated until 10 ampere, but the motor voltage, it will amplify the current. That's why it has 80 ampere here. Right, next we have the next case study. Okay, we are doing like the underwater robot. All right, so as the name itself says, when it is underwater robot, so you need to choose the tools, you need to choose the actuator, or you need to choose all of the components that can withstand underwater. Okay, so for the underwater cleaning robot, the weight itself is 20 kilogram because we wanted to submerge the robot, so the weight must be quite high. Okay, and the speed is actually 0 to 0.2 meter per second. So this is actually the specification lah. what they call the specification of your system. Okay, and this is the motor using, and this is the modulator, right? So this is the design specification of your system. Okay, the weight is 20 kilogram, the speed is this, the acceleration is 0.1 meter per second squared. It has a scaling mechanism. It has the aluminum wheel which has 120 millimeter diameter. The supply is 12 volt DC, right? And tilted power is 60 meter, right? And then the size of the robot, or the dimension, is 50 times 40 times 25 cm, right? And then the actuator they are using is 4 times or 4 units of gate DC motor. Okay, as you can see here, it is using the power window, right? So this is the motor that we are using. Okay, motor power window. Okay, and then as you can see here, the voltage rating is 12 volts. Okay, which is similar to the operating supply. The rated speed is 60 rpm. The rated torque is 2.9 newton meter. Okay, which is 30 kilogram feet per centimeter. 30 kilogram, I'm not sure what is kgf per centimeter here. Right, so rated current is less than 15 ampere at 12 volts. And the stall torque, which is locked at 9.8 newton meter. Okay, per watt, it can only maximum torque is at only 100 kilogram per centimeter only. Alright, and the stall current, it is locked at less than 28 what they call ampere at 12 volts, and the wheel diameter is 120 millimeter aluminium. Okay, so this is the specification for the motor. And this is the modulator, where you have we are using the same, okay, MD3TC, okay, where it can operate from 5 volt to 30 volt. All right, so the motor is 12 volt, so it can operate it. Maximum current is 80 ampere. All right, and the stall current, the lock one, is at 28 ampere, so it is still lower. Okay, and it has a reverse polarity protection. And for the power supply, we are using the power supply of 15 volts at 20 ampere. Right, so this is the design specification of your system, and this is the motor that are chosen based on the specification. All right, and this is the what they call the modulator that we choose. Okay, so first you need to know what is the specification of your system, and then from there you can determine, or you can choose your motor that are suitable for your system, and then from the motor you can choose the motor driver or the modulator, so that it will be able to drive the motor, to move the motor, to actuate the actuator. Right, so that is actually the selection process for your actuator. Okay, that is some of the case study that we can have, right, where you can choose your motor or your modulator. Okay, and this is how you can know, okay, how you wanted to choose your actuator based on your system. Right, so okay guys, I think that's all for our class today. Okay, next week we will continue with the next lesson, which is all related to the DC motor. Okay guys, so if you have any question, please drop down your question inside our Telegram group. Right, I think that's all for our class today. Assalamualaikum and have a good day everyone.